All right, so we're diving into some pretty fascinating stuff today. We're talking polar exploration, ancient climates, a bit of paleontology, and even a touch of, philosophical pondering about our planet's long-term future. And it all starts with this really intriguing discovery that happened back in July of 2000 on Ellesmere Island.
Sounds promising. I'm all ears.
So picture this. You're on Ellesmere Island, way up in the Canadian Arctic. Classic Arctic conditions, sleet, wind whipping around you. And you're not out hunting for polar bears or anything like that. You're actually searching for fish fossils.
Fish fossils in the Arctic, that's not something you hear every day.
I know, right?
Yeah.
And these weren't just any fish fossils. These were fossils of fish that seemed to have had, wait for it, arms and legs.
Wow. That's a pretty big deal. I mean, that kind of discovery really challenges our understanding of how life evolved in those ancient polar environments.
Mm-hmm. Yeah, it really makes you rethink things. And then on top of that, you've got this classic explorer's dilemma. It's time to head back to camp, but you have two choices. A potentially nasty fall down these slick cliffs, or venturing out onto the shifting pack ice.
Oh, I see. A real Sophie's choice of Arctic travel. Not exactly a win-win situation.
Exactly. And it kind of foreshadows this whole theme of unexpected discoveries and difficult choices that we're going to be sort of unpacking in this deep dive.
You got it. So what did you choose? The cliff or the ice?
Well, we were carefully weighing our options. And as we were doing that, something very strange caught our eye on the horizon, this dark shape. Now, judging size and distance in the Arctic is incredibly tough because you don't have the usual reference points. It could be a polar bear, a musk ox, who knows?
Yeah, that vastness really messes with your perception.
Absolutely. So we're approaching cautiously, and it slowly becomes clear it's not an animal at all. It's a jumbled mess of collapsed wooden boards and slats just lying there on this remote beach. And we're thinking, okay, this is weird. Who left this here?
Yeah, that would definitely raise some eyebrows.
We were about 300 miles from the nearest Inuit community, Grise Fjord, a tiny settlement. And there are no roads, no trails, no airstrips. The only way to get there is by helicopter or by foot.
So you're really talking about extreme isolation. It's not like someone just casually dumped some lumber there.
Exactly. This is where it starts to feel like we've stumbled onto something significant. As we start examining the debris more closely, the clues start to emerge.
Look what?
Some of the wooden strips had faded print on them and the lettering looked Scandinavian. Then there was the wood itself, weathered, gray, clearly exposed to countless Arctic winters. But the detail that really made us stop in our tracks, the nails were hand-pounded, you could see the individual hammer strikes, no mass production here. This was pre-industrial age craftsmanship.
Okay, so you've got this incredibly remote location, Scandinavian script, hand-forged nails, ancient wood. This is starting to sound less like random debris and more like, I don't know, an archaeological site or something.
Right. It all pointed to something historic, something connected to a much earlier era of exploration. And that's when we started to connect the dots. These were likely artifacts from a pivotal moment in polar exploration.
And this brings us to Fridtjof Nansen, right? I mean,
Yeah.
you can't really talk about polar exploration without mentioning him.
Exactly. Fridtjof Nansen, a true legend of the Arctic. But he wasn't just some adventurous daredevil. He was a brilliant scientist, an oceanographer, who actually wrote his doctoral dissertation on, get this, the nervous systems of marine invertebrates.
Wow, a true Renaissance man.
He really was. Champion skier, champion speed skater, just this amazing, multi-talented individual with this deep passion for pushing the boundaries in the Arctic. And one of his very first expeditions, the one that really put him on the map, was a crossing of Greenland. Now, at the time, the accepted approach to Arctic exploration was to mount these massive, heavily provisioned expeditions. Think lots of men, tons of supplies, trying to brute force your way through the Arctic.
Yeah, the classic bigger is better mentality.
Yeah, right. But Nansen, he went the opposite direction. He put together a small team of highly skilled skiers, embracing a more agile, self-sufficient approach. He really drew inspiration from Inuit and Alpine cultures, adapting their methods and their knowledge of polar travel. And his expedition was a resounding success. He proved that you didn't need to drag a mountain of supplies with you to conquer the Arctic.
It was a real paradigm shift in how people thought about polar exploration.
Absolutely. And it was that success that really fueled his next, even grander ambition, to be the first to reach the North Pole. Now, keep in mind, the Arctic in the late 19th century was still shrouded in so much mystery. It was a dangerous, unforgiving place. Explorers vanished, ships got crushed by the ice, and the very nature of the far north, whether it was land, ocean, or ice, was still a matter of intense debate.
It was truly the last great geographical frontier.
And Nansen, being the meticulous researcher he was, he actually found inspiration in one of those very tragedies, the story of the USS Jeannette.
Ah, yes, the Jeannette expedition.
Yeah.
A stark reminder of the Arctic's unforgiving nature.
Exactly. This was a U.S. Navy expedition that attempted to reach the North Pole in the late 1870s. Things went horribly wrong. The ship got trapped in the ice, was eventually crushed, and the captain, George DeLong, along with 12 of his crew, perished.
It was a devastating loss.
Absolutely. But here's the twist. Years later, Inuit hunters on the coast of Greenland stumbled upon wreckage from the Jeannette. It had drifted over 1,000 miles in just 4 years.
So it's a story of tragedy, but also a testament to the incredible power of the Arctic's ocean currents.
Right. And for most people, this was just another chilling reminder of the Arctic's dangers. But Nansen, he saw something different. He saw an opportunity. He started to think, could this drift of the Jeannette wreckage be evidence of a consistent current flowing across the Arctic? And if so, could he design a ship strong enough to withstand the ice and actually use that current to drift towards the North Pole?
That's some seriously outside-the-box thinking.
It really was. And that's exactly what he did. He meticulously studied the Jeannette's drift patterns and the accounts of other Arctic explorers. He also immersed himself in learning about Inuit survival techniques, their knowledge of sledge design, how to build efficient stoves for melting snow, the best types of clothing for extreme cold, anything that could give him an edge in that unforgiving environment.
He recognized the invaluable expertise of the people who had lived in and adapted to the Arctic for centuries.
Absolutely. So he comes up with this incredibly ambitious plan. Build a ship that can withstand the crushing force of the ice, intentionally let it get frozen into the pack ice, and then drift with the currents towards the North Pole. And the really ingenious part was the idea that once the ship got close enough, he and a small team would disembark and make a final dash to the pole by sledge.
It was a radical departure from the traditional methods of polar exploration.
It really was. And as you might expect, when he presented this plan to the esteemed Royal Geographic Society, the reaction was mixed, to say the least. You had some people who were intrigued, but a lot of them were just outright skeptical.
I can imagine. It must have sounded like a suicide mission to some of them.
Oh, yeah, there were definitely concerns about his sanity. Adolphus Greely, who had led a famously disastrous Arctic expedition himself, he even called it an illogical scheme of self-destruction. But Nansen was undeterred.
He had a vision, and he wasn't going to let the naysayers stop him.
Exactly. He was also a very skilled fundraiser. He appealed to Norwegian national pride, framing this expedition as a quest for Norwegian achievement. And it worked. He managed to secure funding from the Norwegian government, even from the royal family, to build his ship and recruit an all-Norwegian crew.
That's remarkable. He really tapped into the power of national identity to make his dream a reality.
He did. And that's how the Fram was born. She was a small, sturdy vessel with a revolutionary rounded hull designed to actually be lifted up by the ice rather than crushed by it. Her name, Forward. Very fitting, don't you think?
Absolutely. A perfect name for a ship destined to explore the uncharted regions of the Arctic.
So in 1893, the Fram sets sail. She gets deliberately trapped in the ice and starts this incredible journey across the Arctic Ocean. They drifted for 3 years, reaching farther north than anyone had ever gone before. And remarkably, they did it with 0 casualties and no major incidents.
A testament to Nansen's meticulous planning, the Fram's ingenious design, and the resilience of the crew.
Absolutely. And while they didn't quite reach the pole itself, Nansen and a companion did make a daring sledge journey that set a new farthest north record. He returned home a hero, transitioned into a very successful career in diplomacy, and even won a Nobel Peace Prize.
He truly led an extraordinary life.
He did. And the scientific output from the Fram expedition was immense. They published a massive 6-volume treatise filled with detailed observations and analysis. Nansen really emphasized the idea that polar exploration should be a rigorous scientific endeavor.
It was a significant step forward for the field.
And the Fram herself went on to have quite the adventurous career. She sailed south with Amundsen for his successful South Pole expedition, and in 1902, she was back in the Arctic exploring Ellesmere Island. This expedition was focused on, polar geography, natural history, climate studies, and guess what?
What?
Those wooden crates we found back in 2000, almost certainly from that 1902 Fram expedition, they were likely used to transport supplies as they explored that same fjord where we were hunting for fossils.
Wow. That's an incredible connection. A century of scientific exploration converging in one place.
Isn't it amazing? And there's another little detail that really emphasizes this interconnectedness of scientific discovery. On that 1902 expedition, the ship's natural historian, the youngest member of the scientific team, actually found tiny fish scales in the rocks of that same fjord where we were working almost a century later.
So you're literally following in the footsteps of those early polar explorers.
It really felt that way. And that incredibly efficient sledge design that Nansen developed, the one based on Inuit principles, a modern version of that very design was used on my own expeditions to the Antarctic. His innovations had a lasting impact.
They did. His approach to polar travel revolutionized the field. But let's talk about the broader history of polar exploration for a moment. Nancy's motivations were clearly a mix of scientific curiosity and that human drive to explore the unknown. But the bigger picture is more complicated, right? Nations were also interested in new trade routes, potential resources, claiming territory.
Oh, absolutely. The history of polar exploration is interwoven with all sorts of geopolitical and economic factors. And then there's this whole fascinating story about this idea that captivated so many early explorers, the open polar sea.
Ah, yes. The mythical ice-free ocean at the North Pole.
Exactly. The idea was fueled by a few things. First, you have the continuous daylight during the Arctic summer, which led some people to believe that the region must be warmer than it actually was. Then there was the understanding that salt water freezes at a lower temperature than fresh water. So they reasoned that the Arctic Ocean, being salty, might not freeze completely.
It's a logical line of thinking, but unfortunately not quite accurate.
Right. But this idea of an open polar sea, it held a powerful sway over people's imaginations. William Barents, the famous Dutch explorer back in the 16th century, he was a big proponent of this idea. He saw it as a potential shortcut to the riches of the East, especially the lucrative spice trade.
The Northwest Passage, a dream that lured many explorers to their doom.
Exactly. And even though the open polar sea never actually materialized, those early explorers who chased that dream, they left their mark on the Arctic map. Their names are all over the place: bays, islands, straits. A lasting legacy, even if their primary objective remained elusive.
It's a reminder that even in failure, exploration can leave an indelible mark on our understanding of the world.
And then you have Lady Jane Franklin, a figure who often gets overlooked in the traditional accounts of polar exploration. In a time when women were largely excluded from scientific endeavors, she became a driving force behind the search for her lost husband, Sir John Franklin.
Sir John Franklin and his lost expedition, one of the great mysteries of the Arctic.
Right. He set out in 1845 with 2 ships and 129 men to find the Northwest Passage. They were never seen again. And Lady Franklin, she refused to give up hope. She used her social connections, her influence, her own personal wealth to fund and organize multiple search expeditions.
She was relentless in her pursuit of the truth.
Absolutely. And while her primary goal was always to find her husband, her efforts really catalyzed a new era of Arctic exploration. She inadvertently helped to advance our understanding of the region, even though her personal quest ultimately ended in tragedy.
It's a powerful testament to her determination.
It really is. And one of the explorers who was deeply inspired by Lady Franklin's efforts was Elisha Kent Kane. He was quite a remarkable individual, a geologist, a medical doctor, a true polymath.
He was also a veteran of the first Grinnell expedition, one of the early attempts to find Franklin.
Exactly. And during that expedition, they tragically discovered graves belonging to Franklin's crew. It had a profound impact on Kane, and he became determined to continue the search for Franklin and also to solve this other great Arctic mystery, the open polar sea.
So he was driven by both a sense of scientific curiosity and a desire to honor the memory of those who had been lost in the Arctic.
Right. And in 1853, he launched his own expedition. He headed north, focusing his efforts on the coasts of Greenland and Ellesmere Island. He assembled a really capable team, including experienced hunters and Inuit interpreters, a very wise decision, as it turned out.
The Inuit possessed invaluable knowledge of the Arctic environment and survival techniques.
Absolutely. But despite their best efforts, things took a dramatic turn. Kane's ship became trapped in the ice, and they ended up being marooned in a remote Arctic bay for almost 2 years.
Wow, that's a long time to be stuck in the ice.
It was brutal. They endured some of the most extreme winter conditions ever recorded. Temperatures plummeted to minus 70 degrees Fahrenheit. food supplies dwindled. It was during this time that Kane's medical skills and his collaboration with the Inuit really proved crucial. He knew about the importance of raw meat for preventing scurvy, and he worked closely with the Inuit to secure vital supplies and learn their innovative shelter-building techniques. They used moss and furs to insulate the ship against the extreme cold.
A remarkable example of cross-cultural collaboration and the importance of local knowledge in extreme environments.
Exactly. But eventually, the situation grew desperate. Some of his crew actually mutinied, attempted to escape south on their own. It was a testament to Kane's leadership that he not only allowed them to leave, but also welcomed them back when their attempt failed.
He must have had incredible strength of character to maintain order and morale under those circumstances.
Yeah, he did. But even amidst all this hardship, Kane never gave up on the dream of finding the open polar sea. He sent out sledge teams to explore in different directions. And one of those teams, led by William Morton, actually reached 80 degrees north latitude, a new farthest north record. And guess what? Morton reported seeing open water. Not a speck of ice, were his exact words.
So it seemed like they had finally found evidence to support the open polar sea hypothesis.
It did. But ultimately, survival had to take priority. Knowing they couldn't risk another winter in the ice, Kane made the agonizing decision to abandon the ship. They embarked on this grueling 83-day trek south, eventually being rescued by a passing vessel. Kane returned home a hero, but his fame was short-lived. The Civil War overshadowed everything else.
It's a shame that his contributions were somewhat overshadowed by the events of the time.
It is. But his legacy lived on, inspiring others, including Isaac Israel Hayes. He had actually been a junior member of Kane's expedition. And just a few years later, Hayes set off on his own Arctic adventure. He was determined to continue the search for Franklin and, of course, to find that elusive open polar sea.
Another explorer bitten by the polar bug.
Exactly. But Hayes's claims about the open polar sea, well, let's just say they were a bit questionable. He apparently wasn't the most skilled navigator, and instead of actually seeing open water, he encountered these large fields of floating ice blocks. But rather than interpreting that as evidence against the open polar sea, he somehow convinced himself that these ice blocks were actually evidence for it, like some kind of frozen barrier surrounding this vast hidden expanse of open water.
Confirmation bias at work. Seeing what you want to see, even when the evidence suggests otherwise.
Right. But even though he was pursuing this ultimately incorrect theory, Hayes and his crew did make some valuable contributions to our understanding of the Arctic. They did some mapping of Ellesmere Island's geology and collected fossil shells from the ancient seabed that's exposed in some parts of the region. Sadly, a lot of his specimens were lost, but the ones that remain, they provide these fascinating glimpses into the Arctic's deep past.
So even though his main objective wasn't achieved, he still managed to gather valuable data that would be useful to later scientists.
It's a good reminder that scientific progress isn't always linear. Sometimes even the wrong paths lead to important discoveries. And speaking of progress, think about this for a moment. You have Lady Franklin driving this whole new wave of Arctic exploration, Kane and Hayes venturing to Ellesmere Island and finding these intriguing fossils, and then, decades later, Nansen comes along with the Fram and pretty conclusively demonstrates that the open polar sea, as they envisioned it, simply doesn't exist.
A major paradigm shift in our understanding of the Arctic.
Right. But suddenly, those seemingly unimportant seashells that Hayes had collected, they took on a whole new meaning. His interpretation of the ice was completely wrong, but the fossils themselves, they were actually evidence of a past open polar sea, just one from millions of years earlier. It's a great example of how scientific understanding evolves over time.
It is. New discoveries often force us to reevaluate old evidence in a new light.
Now, shifting gears a bit, let's talk about Antarctica. Human encounters with Antarctica happen much later in history compared to the Arctic. There's this tantalizing story about a Polynesian navigator named Ukeranjuora, who may have ventured into the Antarctic Circle as early as the 7th century. He describes seeing sea foaming like arrowroot, likely referring to the pack ice. But the first confirmed sighting of the Antarctic continent itself wasn't until 1820 by a Russian expedition led by Fabian Gottlieb von Bellingshausen.
Antarctica being so much more isolated and surrounded by these incredibly rough seas, it's understandable why it took humans so much longer to reach it.
Right. And then, of course, there's the famous race to the South Pole in 1912, with Amundsen and Scott vying for the glory of being the first. The traditional narrative focuses on the Norwegian victory and the tragic death of Scott and his team. But beneath that surface, there's this whole other story, a hidden narrative of scientific sacrifice.
Oh, absolutely. Scott and his team weren't just driven by national pride, they were deeply committed to scientific discovery.
Exactly. In his earlier expeditions, Scott had already set farthest south records, pushing the boundaries of human exploration in Antarctica. And in 1909, he very publicly announced his ambitious Terra Nova expedition, stating his goal to reach the South Pole. Unbeknownst to Scott, the Norwegian explorer Roald Amundsen was secretly preparing his own polar bid, drawing on the lessons learned from earlier explorers like Nansen and incorporating Inuit techniques. It wasn't until much later that Scott learned about Amundsen's rival expedition. It was a race against time and against a formidable opponent.
A true test of human endurance and determination.
It was, and the challenges were immense: extreme cold, high altitude, a vast, unforgiving terrain of ice and snow. Reaching the South Pole was, and still is, an incredible feat. But Amundsen and Scott took very different approaches. Amundsen's team was small, lean, and focused entirely on speed and efficiency. Their sole objective was to reach the pole. Scott, on the other hand, led a much larger expedition that included a significant number of scientists. They had a broader mission, not just to reach the pole, but to conduct valuable scientific research along the way.
Scott was clearly committed to advancing our understanding of the Antarctic, not just planting a flag there.
He was. They studied penguin rookeries, explored the geology, made oceanographic and meteorological measurements. They even made some pretty groundbreaking early discoveries, like finding the first fossil fish scales in the Transantarctic Mountains, identifying those enigmatic dry valleys, and documenting the strange phenomenon of bloodfalls.
It was a truly multidisciplinary expedition.
So the final push to the pole begins. Scott's five-man polar party set out on November 1st, 1911. Amundsen's team, just 4 men, had a 2-week head start. And when Scott and his team finally reached the South Pole on January 17, 1912, they were met with this incredibly disheartening sight: a Norwegian flag already planted there, along with a note from Amundsen. The Norwegians had beaten them by over a month and were already well on their way back to their ship.
I can't even begin to imagine the disappointment they must have felt.
It must have been crushing. There's this famous photograph of them at the pole. Most of the men look absolutely defeated, but there's one figure, Dr. Edward Wilson, who actually has this determined look on his face, and he immediately starts sketching and analyzing the Norwegian tent and the cairn they built. It's this remarkable display of scientific curiosity, even in the face of personal defeat.
It really speaks to his character and his dedication to science.
It does, and the return journey, well, it turned into a harrowing fight for survival. They were battling dwindling supplies, brutal weather, sheer exhaustion. Edgar Evans, one of the team members, he died after a fall on the Beardmore Glacier. Then Captain Oates, suffering from severe frostbite and knowing he was slowing the others down, made that incredibly selfless decision to walk out into a blizzard.
A tragic sacrifice.
It was. And then there were 3. But even as they were facing almost certain death, they made this remarkable stop on the Beardmore Glacier to collect geological samples. Scott even wrote in his diary about how Wilson had found pieces of coal containing beautifully preserved fossil leaves.
Even in their darkest hour, they were still driven by this desire to learn and to contribute to scientific knowledge.
It's incredible. And the next day, Wilson made even more remarkable discoveries, more fossil plants, including these incredibly clear impressions of what looked like beech leaves. And these fossils were found in different layers of rock. He had found evidence of 2 different types of ancient plant life while literally fighting for his survival.
It's a testament to his scientific acumen.
Tragically, Scott, Wilson, and Bowers didn't make it. They were trapped by a blizzard just 11 miles from a supply depot and eventually succumbed to the elements. Their tent was found 7 months later, and Scott's body was actually positioned protectively over Wilson's.
A poignant image that captures the bond they shared.
And outside their tent, on their sledge, were nearly 80 pounds of fossil plant specimens collected by Wilson. They carried those fossils with them right to the very end.
It's a truly awe-inspiring testament to their unwavering dedication to science.
And those fossils turned out to be hugely significant. Among them were Glossopteris fossils, a type of plant that thrived in tropical climates around 300 million years ago. And there were also these remarkably well-preserved impressions of fossilized southern beech leaves, Nothofagus. These are temperate climate trees, the kind you'd find in, say, New Zealand or Chile today. But these fossils were from Antarctica, and they were only about 5 to 7 million years old.
So evidence that Antarctica was once much warmer and more hospitable than it is today.
Exactly. And that leads us to this much broader perspective on Earth's climate history. We know that glaciers, as they advance and retreat, leave behind all sorts of evidence in the rocks. We can find glacial striations, till deposits, and even unique chemical signatures in meltwater all over the world.
It's like a giant fingerprint left behind by ancient ice sheets.
Exactly. And then we have to consider the fact that the continents haven't always been where they are now. The Earth's crust is made up of these massive tectonic plates that are constantly, albeit very slowly, moving around. So the rocks we find at the poles today might have actually formed at completely different latitudes millions of years ago. It's a dynamic, ever-changing puzzle.
It's one of the things that makes studying Earth history so fascinating.
I know. And scientists have developed some really incredible tools to help them piece this puzzle together. There are things like atomic clocks found in certain minerals that allow us to accurately date rocks. Then we have the fossils themselves, which provide clues about past environments. And even features within the rocks, like their magnetic properties, can tell us about the latitude where they formed millions of years ago.
It's amazing how much information we can extract from rocks.
It really is. And what's even more remarkable is that for the first 2 billion years of Earth's history, there's no evidence of any major ice sheets. The planet was generally much warmer than it is today. The poles were likely ice-free.
So our current ice age is a relatively recent phenomenon in the grand scheme of things.
Exactly. It's a bit mind-boggling to think about, isn't it? The earliest evidence for glaciation that we've found comes from rocks in Canada that are about 2.2 billion years old. It seems like there was this relatively short ice age back then, followed by a return to warmer conditions.
It's a reminder that Earth's climate has always been in flux.
And then there's this really fascinating, almost unbelievable chapter in Earth's history, the snowball Earth hypothesis, this idea that the entire planet might have been encased in ice. The evidence for this comes from rocks that formed around 710 million years ago, and here's the kicker. Those rocks were deposited near the equator. It suggests that even the tropics were frozen over.
The snowball Earth episodes, if they happened, would have been truly extreme events.
They would have been. And it seems there were actually 2 major snowball Earth events separated by a period of intense warming. Talk about dramatic climate swings.
It really highlights the interconnectedness of Earth's systems.
And after those snowball Earth episodes, Earth entered a much longer period of relative warmth and stability that has lasted for the past 600 million years. During this time, continents like Antarctica and Greenland slowly drifted across different latitudes. The Arctic remained largely ice-free for most of this time, even as the South Pole experienced a couple of shorter periods of glaciation. The dinosaurs roamed a generally warm world, and the rise of mammals and birds also occurred during a time of relatively stable, warm conditions.
So we're actually living in a rather unusual time, geologically speaking, a time with ice at both poles.
Exactly. It's humbling to realize that permanent polar ice caps have only been around for a relatively small fraction of Earth's history, maybe about 10%. For most of Earth's 4.5 billion years, there were open polar seas, not the mythical ice-free passage that early explorers sought, but real vast oceans.
It challenges our perception of what's normal for our planet.
It really does. And the current ice age that we're in, it really only started to take shape about 34 million years ago, with ice first accumulating in high elevations and in Antarctica. It took about 20 million years for the Antarctic ice sheet to reach its present size. The Northern Hemisphere joined the party much later, with the first significant evidence of glaciation appearing around 10 million years ago, and the large Arctic ice sheets that we know today only forming in the last 3 million years.
And these ice sheets have had a profound impact on the planet.
Oh, absolutely. They've influenced sea levels, ocean currents, global climate patterns, the evolution of countless species. They've shaped the world as we know it. And the big question remains, what triggers these major glaciations? Why did Antarctica freeze over so much earlier than the Arctic? The answers lie in those complex interactions between the Earth's rocks, its oceans, and the life that it supports.
It's a puzzle that scientists are still working to solve.
It is. So you see how those seemingly ordinary, weathered wooden crates that we found on Ellesmere Island, they became this unexpected portal into over a century of exploration and scientific discovery. The stories of Nansen, Kane, Scott, they all contribute to this bigger picture of how our understanding of the polar regions and of Earth itself has evolved.
It's a fascinating journey through time and science.
It really is. And it makes you wonder, considering that polar ice caps have only been around for a tiny fraction of Earth's history, what does our current state, with ice at both poles, really mean in the long term? What might the future hold for these frozen landscapes? It's a question worth pondering.
It is. And it underscores the importance of continuing to study and understand our planet's climate system, both past and present.
Couldn't agree more.
Thanks for taking us on that journey. That was a pretty fascinating deep dive.
You got it. Always a pleasure to delve into these topics with you.
Likewise.